The last skill for today is to talk about how to take two linear equations and to find a common solution to them both. I want to find an x and a y that not only is a data point in this first line, but is also a data point in this second line. Or put another way, what I want to find is, here are my two lines, y equals minus 2x plus 1, and then 4x minus 2y equals negative 10. I want to find that point which belongs to both lines. If I have a graph, I can see that that point is the point with coordinates negative 1, 3. But we won't always have a graph. I mean, even if we have a graph, we shouldn't trust the graph, because graphs can't give a precise picture of how two things intersect, right? They can give us roughly, it looks like it's probably about negative 1, 3, but we don't know unless we do the algebra whether that's actually accurate or not. So let's build out the algebra for how to determine the common intersection point between two lines. It's what we call solving a system of two linear equations. So there's going to be a couple different methods that you will practice this semester to do so. But the method I want to talk about today is called the method of substitution. And the idea behind the method of substitution is if I want to find a common solution to both of these equations, what I can do, if one of my equations has one of the variables explicitly solved for, so we know from this first equation that y in a common solution to both equations has to be the same thing as negative 2x plus 1. That means that any place in the second equation where I see a y, I can replace that with negative 2x plus 1. And the benefit of that is it takes that second equation from an equation with two variables in it back down to an equation with only one variable in it. And as soon as we get there, we know what to do. Again, that's a well-traveled road for us by the time we get here. Now all I have to do, that I've done the substitution step, is just simplify out the expression on the left-hand side, unwrap the x, and then I'm done. I know what my x is. And once I know what my x is, I can use my original equation to tell me what the corresponding y is. So that's the substitution step. We just have to carry out the rest of the solution now. Simplifying the left-hand side requires us to distribute multiplication over addition. Negative 2 times negative 2x is going to give me positive 4x. Negative 2 times 1 is going to give me negative 2. Finish simplifying by combining these like terms. 4x and 4x combine together to give me 8x. Minus 2 equals negative 10. Now reverse the order of operations. Worry about addition and subtraction first to get that 2 away from my x. 8x is going to equal negative 8. And then worry about division and multiplication to get that 8 away from the x, to find out that x is equal to negative 1. And now that I know the value that x takes, I can use any of my original equations to tell me what the corresponding value for y is. And the easiest one in this example is to use the first equation, y equals negative 2x plus 1. Now that I know that x is negative 1, I can substitute that to discover the value for y. Negative 2 times negative 1 plus 1. Negative 2 times negative 1 is 2, and 2 plus 1 is 3. And so my solution to this system of two equations consists of both the x value, negative 1, and the y value, 3. We can check, if we want to, by plugging those values back into both of these equations and verifying that they work in both equations, that they lead to a balanced equation on both parts. Checking your answers is always a good thing to do when you can do it, because it's better that you catch your errors than that I do.